Alrighty, CNT140, we're looking at Chapter 13, we're continuing. We just got done talking about different types of terminations, and the splice termination, if you will. They remind us about the different connector ferrule shapes. Over the years, there have been different ferrule shapes on your connectors. Some of the first ones were air gap, meaning the two ferrules got really close but did not touch to each other. And like I say, that's kind of like having two garden hoses really close but not touching. As time went on, flat physical connection, PC physical connection, the connectors touched each other. So now it's like two garden hoses touching each other. A lot less light loss. Then they found out physical contact, they actually kind of radius the end of the connectors. That way the fiber cores were lining up better and touching more. So kind of like almost two garden hoses connecting better. And then some of the more modern ones, now that we have things that are keyed, that they don't twist as they go in, might have actual angled physical contact. They found that the cores of the fibers line up better with the angled physical contact. So there are different ferrule shapes when dealing with connectors, fiber optic connectors. They mention a couple hints for field terminations. Again, or I should say, carefully choose your connector. So again, if you're doing field terminations and you're doing a number of connections in the building, make sure they're all, the LC or whatever it happens to be that the building's using. Know how to use that connector. Have the right tools or the right tool kits for them. Dust and dirt are indeed the enemy for these. And if you're using a polished connection, do not over polish. Single mode requires different techniques, different connectors, different techniques. Change your polishing film and cover connectors and patch panels when not in use. Yeah, that's why there's dust caps on all these. Alright, next section they talk about splices. A lot of the stuff you'll deal with in your buildings, in your premise buildings, is going to be those connectors that we just got done talking about. In some applications, you might actually have two long runs of fiber that get spliced together. And there's two different types that you can use, a mechanical or a fused, where you actually weld the two fibers together. And that's what will remind you of here. There are two different types, either fused and welded or mechanical. Mechanical is I'm just actually taking the two fibers together and I'm using some means to hold them in place so that they're connected, for lack of a better term, just by physically being near each other, and the almost like holding my hand around the garden hose. I'm not screwing them tight, I'm just holding my hand around them. Meanwhile, I can use a fused where I actually weld the two fibers together. In this case, I actually take the two fibers, get them very close in proximity, heat up the ends of the fibers, and then cause them to touch together, and then let it cool, and now it acts like one piece of glass. Alright, so the mechanical, I need some kind of alignment fixture to do that. Here is an example of a mechanical fiber splice. I actually have almost like a plastic housing that I'm going to lay my fiber in after it's prepared, and this unit actually clamps around it to hold it in place. And then you will typically squirt in some kind of adhesive, some kind of epoxy, so that it gets welded in place and nothing can move anywhere. And that's what you have down here. After it's all fitted together, it's kind of glued in place. That's your mechanical splice. Meanwhile, a fusion splice many years ago was kind of like unheard of as far as being able to do in the field, but fusion splicing and the gear for it has gotten so much better that you can actually have a small fusion splicer hanging around your neck, if you will, and fusion splice a cable at the side of somebody's house. And that's actually how Comcast and Verizon would connect you up if you're using fiber to your house. If you're using fiber to the house, fiber to the premise kind of thing. So you prepare both fibers, put them into the fusion splicer. The fusion splicer has electrodes that you get a little electric arc between them, causing a lot of heat. The heat heats up the end of the fibers, and then the actual fusion splicer slides the two fibers against each other till they touch, stops the arc, lets it cool for a couple seconds, and now you have two pieces of glass that are kind of glued together, fused together, so they act like one piece of glass. So to do that, strip your buffer off your fiber, clean your fiber, put it in your cleaver. There's actually a little clamp here to hold the fiber in place. The cleaver itself actually has, it almost looks like a diamond pizza cutter. It's a wheel that looks like a pizza cutter that's like industrial diamond cutter on, and you carefully, as you push this down, the pizza cutter cups up on the bottom and nicks the bottom of the fiber, and then there's a roller over here that grabs a hold of the stub end and actually pulls it off, breaks it off. So you have a nice clean cleave on the end of the fiber. You take this little clamp unit out, lay it into the fusion splicer here. That's what you're seeing here. That little clamp unit is black over here. It's green over here. But you lay it into your fusion splicer. Then the fusion splicer itself heats up to cause the two fibers to join. So here is actually two fibers in the fusion splicer. There's the electrodes. When the fusion splicer starts, a little arc jumps across here to heat up the ends of the fibers, and then the fusion splicer itself takes these two fibers and actually kind of slides them a little bit till they touch and stops the arc and lets them cool for a second or two, and then they act like one giant piece of glass together. The next thing you do is the sleeve slides over top of the joined area and you heat that. This is your splice sleeve is what it's called. They come in different sizes. This slides over top of your fused area. You heat it. There's a plastic tube in here to protect the fiber. Then there's actually a metal spline in there to give it some rigidity so that splice does not break. And that's actually part of the process too. If you look back at your, I'll go back a little bit on the fusion splicer. You would slide that splice sleeve on before you start, and after you're done, you slide the splice sleeve over top of the fiber, and there's a heating unit at the back of the fusion splicer that you lay that little tube down in. It heats up and shrinks it onto the fiber, shrinks it onto the splice. The best splice is determined by things that you need, and like I said years ago, mechanical might be the way to go, but today fusion splices have gotten really good, so a lot of times your fusion splice is what gets done. The fusion splicer itself, they say loss is minimized when fiber cores are perfectly aligned. Yeah, as you lay the fibers into the fusion splicer, what you're actually seeing here on the screen is a camera looking down and a camera looking at the side, looking at the top and the side of the fiber, so to speak, and it actually aligns the two fibers. Here's this fiber on one end, fiber on the other end, and it moves them left and right and up and down until the two cores are lined up and then fuses them. It can't move a lot, but it can move a little bit to line them up. So your placement of the fiber into the tool is critical, and then it does the last little tweaking to line those cores up. End gaps between them cause insertion and return loss, and that would be in like a mechanical splice. End finish of the fiber should be properly polished. Yes. Two sources of loss are directional: your numerical aperture and your core diameter. These are problems that can cause loss and attenuation, insertion loss in your fibers. So they show you here a couple different problems that can happen with either joining two fibers or splicing two fibers. If there's a gap between them, the light coming out of this one tends to spread and only a portion gets into the core of the other one. If they aren't aligned, only a portion gets in. If you have a numerical aperture mismatch, again, it's spreading out and not getting into the other one. If you have dirt problems, it's going to reflect back. If you have end angle, some of it's going to reflect out. And again, they show you all these different problems that can occur, and that's where the prepping of the fiber and good connectors and terminations minimize this. Again, I like to think of two garden hoses coming together. If you do it right, you don't have water squirting out. But if I do it sloppy, all kinds of things can happen that water is squirting out between the two fibers. It's what you're really trying to do here. Get two garden hoses together. Fiber mismatches occur when you have dissimilar fibers. I'm connecting a 62.5 and a 5125 fiber together because it was not color coded, it was not labeled correctly, something of that nature. That can cause some loss and issues. And that's going back to, again, the color coding of the connectors. Hopefully you remember that from the last chapter. The color coded connectors help with that issue. When dealing with some outside plant, a lot of our terminations need to be in weatherproof housings. And they show you a picture of this at the end of the chapter. I might need some additional hardware to protect my splices, my terminations, and my gear using waterproof housings. Inside, I might need special patch panels or splice trays that I bring my distribution cable into. Take the access to it, gets to all the termination points. And that's what we're showing you here, different types of fiber patch panels to bring the distribution cable in and carefully split it out to the different connections in here. I might need some gear to do that. And then here is, actually I have 24 port different types of patch panels, showing you a whole bunch of different options for patch panels. Oops. And then here's also a fiber splice tray. If I were splicing together fibers from one part of the building to another one, or one cable run to another one. Here they actually lay in here, and here's all the fibers being spliced together. As I'm routing fiber through the building, I think we've mentioned this before, but I'll remind you again, a lot of times your fiber is being routed through a building through what's called introduct. Introduct kind of reminds you of like the corrugated hose we use in swimming pools. That gets placed in cable trays and ductworks, and then I carefully pull my fiber through using the pull eye and other things that we talked about previously. And this gives you that low friction pathway to pull your fiber through the building, and when you're done, you have protection for your fiber. You won't have the weight of other cables on top of it and those sorts of things. Alright, so there is our Chapter 13 on our fiber connectors and our fiber splices.